to build our core components for the web part. First, we're going to create the framework structure. We're going to trigger this process at the moment when you perform the first action with the component. It helps us to eliminate the usage of hard-coded pauses. This web component, it's similar to our driver adapter. There will be much better exception message. Hi guys, greetings from Bulgaria. I'm Anton, and this will be our second module out of the course about building advanced test automation frameworks. And we're going to discuss how to build our core components for the web part. Before that, please subscribe to the channel if you haven't done so. Each week I published many new awesome videos and you will be notified. Also, don't forget to check the awesome Lambda test blog, where there are many detailed articles that can help you to be a much better test automation engineer. I'm not going to spend much time again discussing the course overview. We already looked into this overview in the first module where we defined the scope and the requirements about our framework. We did like a research and also we used an assessment system for deciding what are our requirements, what features do we want, and evaluating between and choosing between different frameworks, or ask some questions whether we want to create our custom framework. And after this evaluation, we decided that we want to create a new framework, and I'm going to teach you how to do so. So we're going to start doing that now. First, we're going to create the framework structure. Then we're going to implement many of the test automation framework components. And of course, we're going to use many of the design patterns that we previously discussed during another Lambda test course about design patterns. If you haven't watched it, I suggest to do so. You're going to find all the relevant resources and links to the playlist in the links below. And also, you're going to find the link to the GitHub repo with the source code. What else? I suggest to clone the repo, and in this particular video, I'm going to, you will need to switch to the correct branch about this video. And I suggest to play along, and if it's too fast for you, you can slow down a little bit the speed of the video or increase the speed, but I suggest to check the code along with the video and my explanations. In this particular video we have a lot of code to cover, and this is why I won't spend much time typing the code, right? So let's begin with creating all the framework infrastructure. I always, before typing the code and writing something, I'm a little bit old school, and I always open Notepad and create something that I call development plan. It's always best before directly writing the code to take a pen and write down or use Notepad. So here for us, I created a short plan how to create this web project in the framework. Again, the big difference between a library and a framework for me is that the framework is combining many libraries, but on top of that we can extend it and customize it, and this will be one of our primary goals when we design the framework. On top of the readability, the stability of the tests, API usability, and how easy it is for you to figure out how to use it. So in this particular module, we are going to create the initial projects for the framework. And these initial projects will be the Polaris White. This will be the name of the framework. You can pick whatever name you want, but this is the name I liked and I picked. So this core project will have and contain all of the base classes that we need, all of the plugin infrastructure. Later in the next module we're going to build that, and the core project that we're going to develop now is this polariswhite.web. And To ease our work now, I will put the test that we're going to develop using the framework directly in this project, in this solution. However, keep in mind that in the last module, I'm going to show you how really you should use the framework. We are going to use it as Git submodule, and your test usually will be outside of the original framework repository. So we're going to install some NuGet packages. I'm going to reuse some of the tests that I developed during the series about design patterns so that we don't lose time. Initially, they won't use any framework or design patterns and or just page objects. And later we are going to refactor them to use our framework for web development, web test automation. Then we're going to use the adapter pattern that we use quite extensively in during the design patterns course. If you haven't watched the video about proxy and adapter, you will find the links below. Probably I won't spend so much time to explain it again, but again I will give you a quick overview. So we are going to use adapters. Also, we are going to use the strategy design pattern to develop this kind of reusability of our components and allow the users, the clients of our framework to be able to create new 𝐜𝐫𝐞𝐚 and weight strategies. Something new that we're going to develop are new web components. Instead of having only one adapter for wrapping iWeb element, we will have separate components for example, for the text field, for the button, for the anchor. You're going to see it in a minute how this works. Also, we'll bring something more and implementing lazy loading. Instead of finding immediately the element in the moment when you create an instance of these adapters components, instead of doing that, in order to make our test more stable, we're going to trigger this process at the moment when you perform the first action with the component. For example, at the moment when you type text or click a button. And we're going to add more new stuff like these dynamic validations. Instead of doing immediate assertion, for example, checking a particular label or the total of the website, we are going to bring this I call this validation, which means dynamic assertions that we're going to wait for the particular condition to happen. For example, the price to be updated or to be calculated the right way. This will bring much more stability to our test as well. And in case of any problem, there will be much better exception message. So we're going to refactor the test later using the page objects and of course see our new part of the framework in action, refactoring the existing tests. And later during the next module, we're going to upgrade that using the plugin architecture based on the observer design pattern. It will be quite exciting. So let's get started. First, we need to create the projects. I already did so. So here it is. We have one solution that I named again Polaris-wide test framework, and I created for now these three projects: Polaris-wide web, that will contain all the components for the web, the core, and the demo system tests. Now, I suggest to use this new project functionality in Visual Studio, and for now our framework will be able to support both MS testing and unit. However, I suggest for you to pick a unit, and we can pick directly here from the templates pre-configured project that will come with all of the required NuGet packages installed. You can do this by yourself when you click on dependencies, manage NuGet packages, and click browse and search for them, or When you double click on the project, the MS build definition will be open. This is the language for defining projects in .NET. So in this MS build, as you can see, we have this node. It's XML-like language. We have this package reference. Basically, here is the name of the NuGet package and the version. As you can see, we have all the required NUnit NuGet packages and this Microsoft.NET SDK. That's it, what you need here in the Polaris core. For the Polaris web, the main thing is that you need, of course, Selenium WebDriver that we are going to use, and also you need to add a reference to the Polaris White core project. Again, in this Polaris White project, little by little, we are going to add the different infrastructures like base classes for NUnit, also plugin architecture that we are going to develop next time. For now, we'll keep it a little bit more simpler without the plugin architecture. And for our demo system test, again, it's a regular NUnit project that has a reference to the Polaris White web project. That's it. Nothing more special. Regarding the tests, this is our next part from our development plan. So we have the NuGet packages, we have the projects, and I copied the existing Selenium tests. Let me quickly explain. I created a namespace called noFramework. Also, when something I forget, again, I suggest you to clone this repository that you will find in the links below, Polaris White repo, and clone and trigger this branch build core components for web. And yeah, so under this namespace, noFramework web models pages, we have regular iWebDriver, regular Selenium tests that are using this e-commerce playground website, the Lambda test. Again, we have automated that many times during some of the other videos that probably you have watched. So in one of the tests, we are comparing different products. Going to this particular screen, asserting all the information, that's it. And then the second test is to add to products, increase the quantity, go to the cart, increase the quantity here, verify some totals, going to the checkout, filling the information, verifying some prices here again, and completing the purchase. That's it. Here, of course, I use page objects. As you know, the page objects, they're basically wrapping what's going on each page. So we use properties for the web elements. In places we use WebDriver wait for waiting particular elements to exist on the page or the elements to exist. Nothing really fancy, and we have some actions that we can perform on the page. For example, the checkout. As you can see, we have tons of inputs here. We can fill the user information, we can fill the billing information, and we can have sometimes some assertions. And we have one class that I call website or app. It depends on the term that you want to use. That basically have a reference to all of the pages that we don't need to initialize them in every test class. So we initialize the driver in the setup, and after that we use the page object. That's it. So later we are going to refactor them. I already did that, but I'm going to show you in a minute how this works. And you're going to find the refactored version under this folder framework, under this namespace. Now, before we look into the refactored version, you will notice in my code that I prefer to use global usings. instead of, making up my files very long. So I prefer to put all the usings here. So you will find these global usings files in all of the projects. All right. What's next? Let's open the development plan again. We need to create WebDriver adapters again. Let me open our presentation. Here I copied the diagram from the adapter design pattern presentation. Here we use, in many of the patterns, we use the composition principle. Let me quickly refresh your memory about the composition principle. This is a principle where classes should achieve polymorphic behavior and code reuse by their composition, by containing instances of other classes that implement the desired functionality, rather than inheritance from a base or parent class. And this is especially important in programming languages like C# or Java, where multiple class inheritance is not allowed. In this adapter design pattern, it helps us to eliminate the usage of hard-coded pauses in automated tests, and instead it will allow us to automatically wait for elements to appear, and moreover, it will help us to improve the API usability of our tests. It will help us to adapt the iWebDriver interface here. It will help us to add new methods or change their signature, and especially for the components, since this video is about the web core components. We're going to create many of these web components because we're going to split them. Each of them will have totally new methods. Like, for example, not all of the components will be able, you won't be able to click them or send keys, but instead you have type text, set date, set value, set attribute, and many more methods, right? So the adapter, it adapts a particular interface, right? You change the signature, add new methods, and this is why we have these new interfaces. They're called usually in the pattern they're called target. This is the iDriver that, as you'll see in a minute, I have split it into multiple interfaces like the original architecture of Selenium WebDriver, and then they will define these domain-specific interfaces for client use. And then we have the adapters that we are going to see in a minute how they work. They adapt the interface of the adaptee. In this case, this will be iWebDriver and the iWeb element, and they will adapt our new this adaptee to the target interface. And basically that's it. And also we're going to use strategy. The strategy, this is very popular pattern. Usually it enables to change algorithm's behavior or behavior of something, and we can change this behavior at runtime. Or this means when we write the test, you can change it instead of, every time provide and hard code that to our framework. We will be able to create different strategies for finding elements or waiting for them, and later we'll be able to add new logic to our framework. So let's return to our code. For now, I will close the tests and stick to the folder structure of our web project. First, we have a folder or a namespace for the assertions where we're going to put these validated assertions that we're going to discuss at the end of the module. Then we have the components that we'll spend much time now in this module. These are, these are like anchors, buttons, checkboxes, date, diffs, emails. Later we'll add much more complex. There is a separate module where I'm going to teach you how to create complex such components that rely heavily on JavaScript, like for example working with editors like Word. Then we have the core folder where we'll have our driver factory that we're going to discuss in a minute. We have defined strategies that we're going to discuss. This is the different locators instead of having this by locator. We have page objects, pages, you know what this is. Plugins that we are going to develop next time. Services where we have all of the adapters that are adapting the iWebDriver interface, and we're going to discuss this now, and the weights that are using weight strategies. So, what is a driver adapter? The driver adapter, as we discussed, is based on this iDriver interface. As you can see, this iDriver interface, it derives from multiple other interfaces. I splitted them to make our work easier. So we have the iBrowser service, and it gives you methods for controlling the browser. We have back, forward, refresh, something from the original buttons of the browser, right? But we have one more method, wait for AJAX. As you know, AJAX is responsible for asynchronous JavaScript requests that refresh just parts of the page instead of reloading the whole page. We're going to use this many often. This is why this is new method that it's not part of WebDriver, but we use internally JavaScript. We have an interface for the cookies. We have an interface for finding our new components. We will spend much more time on that. We'll return to this later. We have interaction service, which is about performing more complex actions like drag and drop, double click, click and hold. It's based on the actions API of Selenium. We have the JavaScript executor and the navigation service that's responsible for going to a URL and exposing the URL property. Now, the adapter, as I said, is responsible for adapting the original interface iWebDriver to the new interfaces. And in order to do that, instead of having one really huge file or a class, I use the C# functionality for partial classes. What is the partial class? The partial class helps us to split a class definition to a few files. So here, all of these files are actually a single class called driver adapter. If I open the this driver adapter.browser, it's actually the same driver adapter class, as you can see here. But everywhere we have this partial keyword. So I split it. Every file is implementing a different interface. But when you compile, all these files will be compiled into the driver adapter class. But this helps us to, to ease our work to find what we need. For example, I know that when I click to the cookies file, that everything about cookies will be here. I always prefer to split my files like that, even page objects. So this driver adapter without any suffix here, it just contains all the definitions in the constructor. It basically wraps the WebDriver weight, the actions, and in a minute we're going to discuss this list with weight strategies. We're going to use them for some internal logic. And also one very important class is this driver factory that later during the next module we're going to use in some of the plugins. But as you can guess from the name, this driver factory, it's placed here in the core folder. Usually we use factories to create objects. And this particular class is responsible for the initialization of our driver. For backward compatibility, I use again WebDriver Manager. However, you don't need to use it if you use Selenium version 4.11 or above. For backward compatibility, I use it. You will notice that this class uses heavily static. It basically has, for now, 2 static methods. In the next modules, we're going to upgrade it to contain logic, for example, to allow us to start our tests in the cloud, in the Lambda test cloud, or in the grid. Also, later we're going to upgrade it to allow us to run all of our tests in parallel. For now, it's just single-threaded, right? And we have here a single start method responsible for, this is called a factory method, right? And it's called start. This browser configuration, for now, it contains 2 important properties, browser and browser version. Later, it will contain, and we're going to discuss in the next module, we'll have other stuff like lifecycle execution, which means whether we want to restart the browser, reuse it, or close it just on failure. And later we'll have different executions like grid execution, cloud execution, local execution. For now, we'll just initialize the browser type, which comes from this enumeration, which contains all the different browsers and browser version. And so based on this configuration, we have a switch, and in this switch we're initializing the proper options. We set the browser version so that, again, if you use the built-in Selenium manager, you don't need WebDriver manager, you can delete that. And basically that's it. Later we are going to upgrade it. We are going to use bidirectional APIs, for example, to add some emulations here, to change the user agent, to emulate mobile, to, for example, use geolocation and many other awesome stuff. And later, when we add different configuration files, we're going to, for example, use that for responsive testing. Many new additions will be added here. For now, it's very, very simple, just single method. And we have one dispose method for closing the browser. That's it. And later, if we want to access the driver, we're going to use it from here. So our driver adapter, this means when you initialize it using the new keyword, you're going directly to get the instance to the driver from this static wrapped property. And then we are initializing the WebDriver with the actions and everything else. So the rest of the classes here, they're basically more or less they're wrapping and exposing their wrapping and using this wrap driver. As you can see, this back method is just calling wrap driver, navigate back, forward, etc. However, here we added a new method, again using WebDriver wait and some JavaScript, waiting for all the requests to finish. Then for the cookies, we're doing the same thing. WebDriver manager cookies, deleting the cookies or adding new cookies. For the interactions, we expose it again. You're going to use it the same way while you use the actions class. For the JavaScript, it's a little bit more complex because we have now a generic method for using the components that we're going to discuss in a minute. But basically, again, behind the scenes, we are using the execute script. For the navigation, we just have for now URL and go to URL, nothing more fancy. And we can use later, in the next module, I'm going to show you how we can use extension methods to add new methods to the adapter and to add new find strategies and wait strategies. Now let's focus on, before we move to these find methods, because they're one of the core things that we're building our framework. Instead of having just why can this test without the framework, without every time using the find and then by. For me, this is a lot of typing, because imagine you have this locator, you need now to place the bracket. Next, you need to type by. Then you need to put a dot. Then you need to pick something. Then you need again to place brackets. Then you need to place two quotes, etc. It's a lot of typing, right? For me, it's much easier if we have methods like right now. I'm going to show you just the parts how we find elements with the refactor version with the framework. Now we have something similar to the website class that I showed you. I call this application. This application gives us access to all of these services or interfaces part of the adapter. And as you can see, this when we initialize that, actually this is just initializing the driver adapter. But since it's split it into multiple interfaces, we have access just to the methods part of the browser, from the navigation to the cookies to the interactions. And instead of having this long name, I call this elements. This elements property is giving us access to all of the methods for locating elements. And the way this works is, again, as I told you, the components adapter is actually not a single class, but many different classes. In a minute, we're going to discuss the pros about this approach. It's a little bit more complex. We have more classes. However, we will have specific classes about each component and much more methods based on the attributes of the web element. But if we focus now on just locating the elements, for me this is much simpler. Just when I type find by, I have the IntelliSense and I have all of them. Before this was possible, for example with APM, they removed that and they used this approach just internally. I understand all the approaches, they have pros and cons. For me, this is faster typing instead of, again, having this approach with the by class. And the limitation about the by class is that everything there is static, which means that you cannot extend it, you cannot add your custom methods. Here this is possible. So here we have less typing, and also we have lazy loading that we're going to find next. So let's discuss first these strategies and what they give us. Let's open the locators folder. So this locator folder, again, the strategy is based on a base class. This is the base class, the abstract class for all of the strategies. This is a very simple base class. It just contains an abstract method that it's converting the strategy and it's returning the native Selenium by, and we have the actual value, the actual ID, the actual XPath, etc. That's it. And then for each specific locator type, for example, if we want to locate something by ID, we need to use the ID find strategy. This ID find strategy, as you can see, we need to provide the actual value using the constructor, and then we override implemented the abstract method by just calling by ID, providing the value. The same goes for XPath find strategy. The convert is just calling the native by XPath. However, it goes interesting when, for example, we have inner text containing. And as you can see here, this inner text containing is something that we don't have natively in WebDriver, which is fine. I mean, this is something that frameworks should add. They provided us just all of the core functionalities, and then later, using such libraries and frameworks, we can extend that, which is completely fine. This is not something like a cons of WebDriver by itself. So here I'm using this complex XPath by containing a text, and this is awesome because we're not going to we're going to reuse it. We are not going to type it every time. The same goes for ID containing, but here this time I use a CSS selector for the ID containing. So these are the strategies. Later, when you use the framework as a user, you can add your own strategies. And next time we're going to do that. We're going to create such a strategy for example, finding elements using XPath access and finding an element by label. And I use this very, very often in enterprise projects. The same goes for weighting strategies that we are using inside our components. These weight strategies, we have this abstract base weight class. It just initializes some timeouts and sleep intervals and provide some core classes that internally they use WebDriver weight, nothing more. And every weight strategy, it needs to implement this wait until that accepts a find strategy. For example, we need to, for example, this to exist wait strategy, it will wait internally. It will wait internally for element to exist. Again, it's completely fine. You can use some of the expected conditions functions if you don't want to create your own. I created my own just for the sake of the example. And the same is valid for to be visible. Here we're checking display property and whether the element was found or not, etc., etc. And now we have if we check how this find service works. This find service, as you can see, all of these methods, they accept a new strategy, right? New find strategy, and we're providing the ID. And this will return a T component. This T component or this generic parameter means that we're going to change T component with some of these classes. Button, anchor, checkbox, date, all of them, they derive from our base component. This is our base adapter. In a minute, we're going to see how this works. But yeah, this web component, it's similar to our driver adapter. I just, on purpose, I didn't use the word adapter, but if you prefer the word adapter, it's fine. But this web component, this is the base class for all of the other web components. For the buttons, for the checkboxes, basically this is the class that contains, this is the one of the main additions. All of our web components now, they wrap the iWeb element. We use here composition. So it consists, we're wrapping the iWeb element. Now we know how our iWeb element was found. And also we are going to add lazy loading, which means that we're not going to immediately find the component, but later. We're going internally to wait using the wait strategies for the element to be found or to exist or to be clickable. And we're going to add new elements there. In order to achieve that, again, we're going to return to this method. It's called find component. All of the rest of the methods are calling this find component. You will notice that it accepts a find strategy, is generic, means that we're going to create any of these classes here, because all of them derive from web component and also they have an empty constructor. So we're creating an instance of them. We're not, as you can see, we're not triggering the native finding. We're not calling driver.findElement and converting. We're just creating an instance of the class. And we're just initializing the find strategy, we're initializing the WebDriver, and we're returning it. Which means that every time here, when you create an instance, this will create an instance of your text field, but we are not going to immediately find anything. We're just creating an instance of this div, date, etc. And the moment when we're going to trigger the finding and everything is much closer to the actual action. For example, when you perform the type text here, this is our text field component. This text, as you can see, this type text, it's calling the base text type text. And as you can see, the type text is similar to what we did with the WebDriver. It's calling our wrapped element. This wrapped element, as you can see, is returning our native iWeb element. And if we open that, you will see that now the empty constructor is just initializing the list with white strategies. We have some interactions in JavaScript service. Internally, we're using the driver adapter. That's it. But the whole magic is happening inside this property, the wrapped element. We're checking, is our wrapped web element no? By default is no, because we just created an empty instance, that's it. But the first time when we want to execute an action, for example, performing a clear or send keys or clicking in, we're going to check, is it no? Yes. Then we're going to trigger now the lazy loading and find the element, and we'll provide the find strategy that we assigned. And as you can see here, next, another important thing for our web component adapter is happening for our web components. The stability of the framework is very essential. As I said, we're using the adapter mainly. One of the core reasons is to perform these weights internally, no matter whether this is just to exist or to be clickable or to be interactable, many different things. But we're going to check our list with weight strategies. Do we contain a weight strategy? If we don't, then every time we're going to at least perform one strategy, and this will be our to exist strategy. This means that every time we'll at least check whether this particular element is visible, exists on the page or not. So we're going to for each this list, and as you can see, we're going to call the wait until method for this particular strategy. As we discussed, this method, this abstract method that comes from the base class for all wait strategies, is implemented in all of them separately. This means that to be visible wait strategy, it will call in this wait until method, this method, element is visible, and we're going to check the display property. For the clickable, we have other logic. For example, we will check that whether the element is enabled or not, etc., etc. So our job first will be to execute all the wait strategies. Just after that, we are going to perform this find native element method. And it's a very simple method. As you know, in WebDriver, we have two ways to find an element. We can search for it inside the whole browser. This means that we are going to trigger and execute the find element of the WebDriver. Or if we set a parent wrapped element, this means that you can, for example, search inside the div or inside the whole table. Then we're going to search inside the other element. That's it. And because all of these native methods, they require the native by, we execute the convert method that will basically convert the find strategy to original by. And that's it. We're going to initialize now the wrapped element, and afterwards, every time when you call the wrapped element property, we're going to return the already found original native iWeb element. And another interesting part is actually how we initialize. This is part of the API usability and from what the framework is actually giving you. Check it out, it's very awesome. As I said, by default, we are always checking internally. Even if you don't type anything, we're going to wait for an element to exist, because we add, if the wait for strategy is empty, we're going to wait for the element to exist. And now look, this is how we search for them. app.elements.find. Here we provide as a generic the type of the element text field, select, etc. And afterwards, you'll see that we have a fluent interface. and here I can say to be clickable, but this means that this to be clickable, in a minute you're going to see how this works, but it will add, this to be clickable will add a new strategy to our wait list. However, since it's using a fluent interface, I can add one more to exist. Then I can add one more to be visible. And not just that, I can even provide some timeouts here. This means that, as you can see, there is an overload. There are two overloads. I mean, one of them is accepting the timeouts by default, but also I can, for certain cases where I don't need to wait, for example, for 60 seconds or to do it faster, I can adapt that. And the way this works, I have here another class called Web Component Extensions. As you can see, this is a static class called Web Component Extensions, and all those classes to exist, to be visible, etc., they're generic methods, and they're extending T-component. This means T-component, as you can see, this type is actually, I'm extracting my framework that this T-component derives from Web Component. This means that this method is extension method for all of these types, because all of them, they have for a base class the Web Component. Then we're just creating a new wait strategy, and then we're calling this method ensure state. What is this ensure state? It comes from my base Web Component class. It's just a single public method of our base web element adapter that is just adding a wait strategy to the list with wait strategies. That's it. And later, since we use that inside our wrapped element property, we're going to trigger that, and this will be executed inside the for each loop that we do here, right here, right? When we find the elements. Besides that, nothing really special in the base class for the web components. Everything else is just, again, when you hover, we're using the interaction service to perform that, to move to the element. When you, for example, have enabled in displayed, we're just calling the wrapped element and nothing more. I added some new methods. This is why we need the adapter. As I said, we're creating a new interface. We're adapting and adding something new or changing the signature. iWeb element of Selenium doesn't provide a method for setting attributes. However, this is really important for us, especially if we want to automate HTML5 components that I'm going to show you in a minute. And here I use some JavaScript for that. And we're using, actually we can use directly the JavaScript service here, etc. Another important thing, since I don't want, as I said, all of my components to be, to allow you to click them. For example, it doesn't make sense for you to click, I don't know, a date. Maybe you can set the date, but it doesn't make to click it, or it doesn't make sense to click on a text box. You're going just to call a type text, which by default maybe it will click inside it, but you don't need the click by itself, or it doesn't mean, for me, for example, if you have a div or a span, it doesn't make sense to click them. Instead, you're going to use the button. And this is why, as you can see, we define these methods. We have a definition for them inside the base class, but they are protected. These methods are protected. This means that when you use the button, by default, you don't have access to this. You need to expose it. And this is why, if I want to implement my component, web component to implement, and allow the users to click, we need to use the new keyword now and call the base definition of them. There are different ways to achieve that. I prefer, in order to achieve some code reuse, to have some definitions inside my base adapter. So I use quite extensively this approach with the new keyword. In order to distinguish and decide which components to create here and what methods do you need to add. For example, this date component is very interesting. It's let me show you the way how I decided what classes to create here, what classes for the web components. I opened this website. Occasionally, if you are a fan of my videos, probably you watch some of them on the 𝐜𝐫𝒕𝒐𝒏 YouTube channel. In a few of these modules, I mentioned this website. I really like it. MDN Web Docs. This is a website for the developers from Mozilla, the developers of Firefox. And this is like a full documentation of JavaScript and HTML. And here we have very detailed information about this input type date. This is this sort of web component. It's HTML5. And by default, if you use send keys, probably it won't work. And also you need to make sure to format really carefully the date here as a string. And also for each of these components, we have different additional attributes. The attribute is, for example, the value is attribute, the min is attribute. But these attributes, they're totally different. We have some global attributes that are, shared among all the HTML elements. However, there are some attributes that are valid only for inputs or just for particular type of controls. For example, here we have min, step, placeholder, and others. This is something I think that we need to assert in some cases. For example, there might be a requirement that from usability perspective that a particular component should allow autocomplete, or whether it's read-only, or whether it's required. And instead of every time parsing and calling get attribute and providing these strings, etc., in all of the components, I believe that our adapters, our components, should expose that by default. And this is what I added here. You will notice also that in this web component, I used quite extensively the keyword virtual. And this is a specific for C#. In Java, all of the methods in the class are virtual by default. You don't need to use this virtual keyword. This means that in child classes of this class, you can override them. However, here this is not possible if you do not declare that this is possible. This is why I want my clients to be able, the users of my framework, I want for them to allow them, if they need to change how this behaves, how this works, for example, how the click is working, or how we get the value of this is read-only, they can just create a child class of this date and they can override it. That's why we use quite extensively here virtual. Also, one more thing, that it's really the power of this adapter design pattern, and especially what we did here. Again, instead of having send keys, here this is especially important for the date, because this won't work here, or it will work strangely. Here I changed totally the signature of this. I changed the name. We have now setDate method. Then instead of providing just a single string, now we have 3 parameters here to ease your job. We need to provide all of the data here as integers, and we're providing them, we're formatting them later as strings using string interpolation, the right format that the controls accepts. And then this new method part of our web component, we use JavaScript to set the value attribute. This is how this component is working. Awesome, right? And I did the same thing for the text field. As you can see here, we have autocomplete, read-only, required, and later we can assert them. So we're going, and for example here, we have this type text, but again, it doesn't make sense to allow you to have a send keys, for example, for the div. This is why the div doesn't contain anything. You can just get the text and the inner HTML. But the text field, instead of having just send keys and be sure that you clear everything inside this input, instead of that, you have type text, and then we are calling the base method here, which is protected, and as you can see, we are reusing that. Even here, we can always, for example, execute the to be clickable wait strategy. That's fine. You can do that here. One more thing that we haven't discussed yet before we wrap up this video is about this was part of our development plan. We implemented the lazy loading already. We haven't discussed the validations. What are these validations? Well, as I said, if you look into checkout here, imagine that we are increasing the quantity and we update that. As you can see, the quantity can be, it depends on the website. As you can see, it was updated without refreshing the whole page. This was done using AJAX requests. This means that we can use the new wait for AJAX method. However, here, if you use a regular assert, sometimes if you don't use WebDriver wait, and depending on when you found this particular label, maybe it will contain the old value. It won't be refreshed. And it really depends what you want to verify, whether something exists or not, or whether, for example, if I click here, continue, maybe you want to check whether these messages appeared or whether they are visible. So I want, instead of using assertions, here in the checkouts, I developed another functionality, which, as I said, instead of using this regular approach for that, and for me, this approach of using asserts that something, then comma is dot equal something, this is very hard to type and it's time consuming. Instead of doing that, I have a new functionality added called validate. As you can see, for each component here, for example, this is my this is a text field. Actually, this is a label. For the label, as you can see, we can just check whether it's visible and what is the inner text. And this is just in TailSense now in Visual Studio. This validate will wait internally for the price to be changed to this. It will wait for 30 seconds. But it's more than that. Every component knows and can verify only the attributes that it contains. For example, the button will be able to verify whether it's visible, will be able to check the value, and whether it's disabled. Let's see, let's find the button. For example, continue button. If we have the continue button, you'll see that we can check the value and whether it's visible. If we check, for example, the checkbox, we can check whether it's checked. But you know, you saw that for a regular button, we don't have this method. But if we see the definition of the checkbox, you will see that we don't have such methods here. How this works? Well, we have the magic of these interfaces here. We use them for two things. First, we use them to implement the adapter design pattern, similarly to what we did with the contracts for the driver adapter. They're very simple. They're part of this folder. For example, we have 𝐼Component checked, whether something is checked or not. We have 𝐼Component click that defines that my component should be clickable. We have is disabled, whether we have text, whether we have autocomplete, etc. So we use them like a Lego. For example, the checkbox, we implemented 𝐼Component value, 𝐼Component disabled, and 𝐼Component checked. And after that, under the assertions folder that I told you about previously, we have these validate component extensions. We implemented extension methods, but we are not extending the actual components, but we are extending specific interfaces that my components are implementing. As you can see, we accept T, but this time T is just the components or the types that are implementing a specific interface. This means that this method won't be visible for components that, or maybe this method won't be shown for components that are not implementing 𝐼ComponentValue, because we have such. For example, div doesn't contain a value, and this means that this won't be available for the divs or for the spans. And the way this works is that we have this base wait until. This is just a method, a static method here at the bottom, where we are just using WebDriver wait to wait for a particular condition. If the condition timeouts, then we are throwing a specific exception with the specific exception message that we provided here. This is another benefit of using this validate method. So we are providing a very detailed message of what happened. The component should be not checked, but it was. And even we can provide a URL. This is actually something that I'm doing here. So I'm saying this component should not be checked, and the test failed on this particular URL, which is quite awesome, right? And again, we're using lambda expressions to provide, this accepts a function of bool, which means this is anonymous function that is returning a boolean or a simple boolean condition. In this case, we are checking whether the component value contains something. That's it. And then we use string interpolation to format the exception message. And as I said, we have, and right here, by default, we're using the default timeouts, but if you prefer, in particular cases, you can even set your own custom timeouts, which is quite awesome. If we look into the refactored framework tests, where basically they're looking quite identical to what we had before. Actually, this is the no framework, and right here we use our app to create some page objects. Again, we have similar base classes, and maybe the biggest change again is that right now we are using here the driver factory. This is important. We need to use the driver factory to start the browser, and then we need to dispose it at the end. After that, everything works like a charm. We're using the framework, and in the next module we're going to extend that. We're going to create some plugin architecture here, and we're going to add new plugins for controlling the browser. Instead of repeating that every time, we'll be able to switch between the browsers. We will be able to control the life cycle of the browser. For example, reuse the browser every time or restart it just on failure. Also later, we'll be able to execute it in the cloud, or for example, mark whether a test is passing in Lambda test or a failure. We're able to highlight elements and much more. All right, you saw the refactored version. We're going to work on that much more later. Again, in this particular video, we saw how we can implement and combine together the adapter, the strategy design pattern, the factory pattern, also page objects and app design pattern. Again, in the next video, we're going to work on this plugin architecture for building customizations for our framework, allow you to bring much more extensibility. Again, the big difference between a library and a framework is this particular feature for extending the framework and customize it for your particular needs. So we're going to proceed with that next time. And also I'm going to show you how we can create and extend various points of our framework. Thank you for watching. If you have any questions, put them in the comments below. Also check the awesome Lambda test blog, because there are many detailed articles to help you to be a much better test automation engineer. And don't forget to get your free certification. See you in the next video. Bye.